All right, once again, I wanted to thank everybody for spending some time with us today to go over the second of three parts of our What's New in SolidWorks 2015 series. Today's going to focus a little bit more on simulation, a little bit of data management, and just some SolidWorks drawings and e-drawings to finish up. So what we're going to do is just get started simply with a couple of things within our PowerPoint and some things I'd like everybody to be aware of. MySolidWorks.com is an area that SolidWorks started a couple of years ago, and essentially it's a gathering place where you can set up your own dashboards free of charge. You can just go in and log in and set up a username and password. But essentially the tool itself is built to really combine the several data streams that we have, things like blogs, user forums, Facebook, YouTube. There's lots of different places that you can go to get your data. And MySolidWorks.com is more of a one-stop shopping area for that. What it also has is additional information. So it cohesively puts together a lot of the information that we post on our blogs and reseller websites as well. But they're also building up hours of online training. So it's more of a train at your own pace type of thing that you'd see. So there's other things that come along with this as well, and they're really starting to branch out into other areas of the service. So cloud-connected storage is much like Dropbox or Google Drive or OneDrive. A lot of different things like that, and there is some of that available to any of you that are on subscription service. There's integration with e-drawings for viewing and being able to place files out there for other people to consume, as well as the different learning streams of data, whether it's 2014 or 2015 data, or even certification prep courses. And then there's the manufacturer's network. That's been out there for a long time, and it's a place where you as a subscription service customer can log your company in, place your profile up there, what you're capable of, and other SolidWorks users that are trying to get parts manufactured with maybe your capabilities or has a like-minded goal in mind that you could be helpful with. It's a place where they can come and actually find you and be able to connect with your services. The capabilities are really simply listed here. No matter who you are, you can log in and get some access to some online tutorials, the blogs and user forums and other things. But what you also get is access to things like the My SolidWorks standard if you're a subscription service customer, which includes a little bit of that cloud storage, viewing your e-drawings online there as well, and then content that's posted by resellers as well as some additional learning. There is a subscription service model to this as well. Not really sure what that cost actually is. Get a hold of a salesperson if you are interested in that, but that would access even SolidWorks certification prep courses with that level. So just wanted to put that out there. Let's go ahead and switch over to simulation. Several new things with simulation as there is with other areas of SolidWorks. We're going to start out actually with nonlinear. When we're taking a look inside of the SolidWorks user interface, let's get over to that. I've got this plastic part here. It's actually three components in a little bit of a plastic assembly, and I want to show you a couple of performance increases. First thing we're going to do here is actually a nonlinear dynamic simulation, which typically means very long processing time and somewhat of an intense type of a study. Well, here we're going to actually go ahead and solve this live for you. The performance has increased significantly within the server, and it also creates these profile paths and these steps as we're seeing the study simulate. Usually you'd have to wait until after the simulation completed to be able to come back and see what the animation looked like. But if there's something that you can uncover, say in this area, that's early on within the simulation process, that would allow you to cancel out of this and maybe go make that change and then simulate it, instead of waiting for the full length of the simulation to take place. Now that being said, this one here is really taking about 30 seconds or so to simulate, and this is all live, but it is plastic, nonlinear, large displacement deformation. So seeing that live is one part of it, but just the performance is significantly another. I've got another one that I've already solved on this. I just want to show you the animation of. This is three parts coming together. But what we get out of these simulations is the ability to find out problems much earlier in the design process. So how these parts are going to clip as one, but check this area out over here. You can see all the movement that we get and all the clipping and snapping that takes place as those pieces come together. So if this is the design you're looking for, we can prove it out in the system before any chips hit the floor and any parts or prototypes are ever generated. But much earlier in the design process, simulation should be injected. We're going to switch to a different part of simulation now, and it's this thing called a load case manager. Now, load cases are really just studies when it comes down to it. When we're taking a look within the SolidWorks interface, studies can be a fairly unwieldy thing to be able to organize. You end up with a lot of tabs along the bottom, and within those tabs you really don't have a whole lot of feedback as to what the settings are in each of those scenarios. So I want to show you this tool we've created called the Load Case Manager. When we go ahead and actually look at the manager, essentially what it is a tabular format for being able to set up different scenarios, and then those scenarios can have different settings for each of the inputs. So when you're looking at things like your fixtures and loads, we've got 3 boundary conditions from fixtures, and then down here we've got 4 different loads, different directions, gravity, and torque. And what those settings are for each study is not always the most easy thing to look at. And how you can switch them for different scenarios is also a difficult thing because we're changing those settings per tab. Well, here in this load case manager, we can simply go ahead and create different load cases. And in those, we can choose to suppress or activate different restraints, as well as the loads, whether they're suppressed or whether they're on, and then what the value of that load happens to be for that particular load case. It's as easy as clicking here to add a new one. We'll call it whatever we want. And now I can go ahead and turn on whatever, in this case, restraint or force I want to put on, which is going to be the torque force. You can also go ahead and create these load case combinations. Now what a load case combination amounts to is different scenarios combined with each other in a different way. So if I wanted to do a scenario here, for example, where maybe I wanted to go ahead and take this 20G vertical load and I wanted to multiply that by, whatever, 2 times something. Well, 2 times the lateral movement would be great. So that would be just a different way to set up a combined or a more powered type of study here. Now, just in the interest of time, I'm going to switch over to a tab that I've got where these load cases are run, and then we're going to go to the Results tab. Another tabular format, what this is going to do is lay it out in such a way that we can see what the results are side by side as well. So, for example, if I'm looking up here in my graphics area and I want to take a look at, we'll just take a look at stress. Stress is going to give me this colorized plot. But when we want to look at the different load cases, we simply select downward, which means downward had 2,000 newtons turned on, and then here is going to be our resulting displacement and stress. Lateral was not using that downward force. It was actually using the right load. But as you take a look at the part changes for each one of these scenarios. We're seeing the plot as if we're activating the plot for that tab. Again, only in this case, it happens to be more side-by-side, comparable, as well as a one-stop shopping interface to make these quick changes. I'm going to switch over next to this dynamic plot that we've got in this tab. When we're doing dynamics, there's a lot of inputs. Really, it's more irregular in many cases, whether it's a harmonic or done by a plot or a text file that's giving different forces. When we're dealing with any type of dynamic responses, the input is going to be our load case, but then our output, our results, are going to be how we read that. And all along with dynamic simulations, we've been looking at these things called frequency response graphs. Now, this frequency response graph tells me very little, tells me some, but very little. Tells me that the magnitude, the highest part that we had here, happened to be around 436 hertz with our frequency. But other than that, the rest of this data is really kind of unusable. So what we've created is a new results plot, and it's called a frequency response graph. What this gives you is the capability to use the effective mass participation and show these things in more of a bar graph type of a way instead. And here it's really easy to see where the Z component, the Y component, and the X component really contribute these different mode shapes. First mode shape, obviously, Z is the maximum contributor, where in the second mode shape, Z doesn't come into place at all. But it does show up in other areas and a little bit lower loads in this particular case, the mass participation. We also have a plot similar to this, but a little bit higher order, that's called the cumulative effective mass participation. And what that's going to do is show this in a different type of a chart, but it gives you the same detail that we can glean. So here early on in our mode shapes at the frequencies, we're getting very low X and Y values, but Z is very high. And then as they start to converge at different modes, we can see that Z moves more to the middle where X and Y are going to bracket that a little bit more. But in any event, it's much more usable data to glean off of this than we had in previous types of charts. I want to move over to a different type of simulation here briefly. This particular simulation is going to have to do with thin wall geometry. Now I want to bring up an assembly of this situation, but the assembly is really a mixed situation. The assembly that we've got here is built with a lot of thin wall parts. Now those thin wall parts can be 2 different types of things. Down here we have surface modeling, so zero thickness geometry in effect, and then here we have a sheet metal part. Also thin wall geometry, but this one is solid. It does have thickness to it. So this is handled in a couple of different ways with this release. When we're setting up any type of a simulation using thin wall geometry, generally we're using shell meshing. And through the normal interface up to 2014, we'd always go ahead and create a study, And then with that study, we'd go ahead and define the thickness of each of the pieces of geometry. And in order to see the thicknesses, you'd have to edit each body within the parts tree. Very difficult, especially to change things, especially when you're changing several things into a new value. So what we've created is this brand new thing called the Shell Manager. Now what the Shell Manager does for you essentially, excuse me, I want to do a different one there. What the Shell Manager does for you essentially is it gives you the one-stop shopping type of input, much like the Load Case Manager. It's going to show you the different bodies that are participating on the screen. We can see that these bodies can be grouped together, and those groups are effective when we're making changes. Each of the bodies, as we select them, will show up as a highlight on the screen, so it's very simple to see which body it is. And then very quickly, we can see what the thicknesses of each of those are. Now, things can be sorted based on these column headings, but you can also colorize them that way as well, which is not only going to color our shell tool, but it's also going to color graphically the geometry on the screen. So the Manager column is going to go ahead and mirror exactly what we see out here for color-coded parts. And it's really effective to make changes as well. Not only can I see all the parts that are 5 millimeters, on screen they're all green, but most of them are part of this base lateral group. And if I was to go in there and change one of those from 5 to 6, you'll see that the entire group is actually about to change as a result of that one change. Pretty time-consuming before, but also very error-prone when we had to edit each of the bodies in order to make that change. So a great interface to make those changes, also some control over the type of geometry, whether it's thin-walled or in this case thick-walled geometry. Determine the thickness from that. Something that used to happen back in 2014 has also been addressed in a very nice way here in 2015. Here's a 2014 simulation of this particular file. And what would happen is on thin-walled geometry like these sheet metal parts, these parts would be simulated without any type of bonded contacts to themselves. We've always had contacts from one part to another, but not amongst itself. So when we go ahead and do a stress plot or an amplitude in this case, this part would actually peel away from itself because there was nothing bonding this flap to this part of the sheet metal component. Well, now in SolidWorks 2015, those types of sheet metal components with adjacent faces are automatically going to get a global bonded contact. So in the 2015 simulation of this, if we look at the same parts, you'll see that that sheet metal part actually holds true and creates a much more sturdy representation of what that file is actually here to do. So a couple of really nice additions just in quality of study and ease of use moving forward with these tools here as well. We've also added a great deal within the system here for performance sake. There is a new solver. The new solver itself I don't have a lot of performance data on, but the new solver is just going to work for different use cases, and it is faster than the solvers we have currently, especially when it comes to more dynamic and nonlinear types of simulations. But what you can also do, regardless of the solver that's being employed, is help yourself by using things like symmetry. We'll talk about self-contact here in just a second, but symmetry is a way for a user to go ahead and really pare down the entire domain of an assembly or a part file, if that may be the case, for simulation. This happens to be about a 1/8 pi piece of the actual brake rotor that we've got here. However, when we go ahead and simulate it, we can use inputs on adjacent faces here called symmetry. Now, when we call these symmetry, it's realizing that there's other geometry both to the right of these faces and to the left of these faces. But it's going to simulate it with the domain that you see on the screen currently. So it runs extremely fast. In this case, 8 times faster than it would have previously with the full domain, computational domain in place. Here we can take a look at the stress plot, and just for the sake of clarity, let me get rid of some of the boundary conditions. But I want to animate this one just to show you what this looks like. It gives you a really high quality animation. We're just going to go ahead and cycle this back and forth. So that looks great. However, we're not sacrificing results with this. In any situation, you can go into these plots and edit their definition. And under the definitions here, we have this area called Display Symmetric Results. So even though this was physically simulated as a 1/8 pi piece, we still have the capability to go ahead and show the results as the full computational domain of the assembly. So we get a really, really great mix of performance, but we don't sacrifice quality or our results visualization. So both of those are really tremendously important. We've also had a situation in the software where we've had contacts available from one part to another since as far as I can remember. We've never really had a great way to determine where, especially in large displacements, parts would contact themselves. So here I want to show you a nonlinear study that we did with this spring, which of course is a classic example of a part collapsing onto itself. We take a look at the animated version of this. Once again, I just want that to cycle back and forth. We can see where the spring collapses back onto itself, and as it does hit and self-intersect, then other things around there are going to have to pivot and stretch in their proper directions. So both of those great additions to the software. Now, in different areas of simulation, let me just go ahead and get out of this for a second. There are different areas within simulation that we also cover within this release, one of which is flow simulation. Now with flow, we've got a couple of really notable things here. One is called a rotating mesh region. Now in areas where the flow is created by something that's internal to the fluid itself, in this case an impeller or an involute, we've always been able to simulate those, but the part itself had to have some representation. This one here is creating the flow, so we'd have to put some turbulent type of value in there and some mass flow rate in order to simulate what it would generate as a real part. Well, with a rotating mesh region, we can actually have that body in there as solid geometry. And instead of it just being in static position, which it would then more serve as baffles more than an involute or a pump, in this case it would actually go ahead and allow us to rotate that mesh region, fully simulating exactly what the input of this in-fluid type of a body would be. So not only can we use it to up the flow, but it's also going to disrupt the flow based on the geometry that is within it and give us great feedback when it comes to any types of problems that might result in that. We also see the preparation results while we're solving. So much like you saw with the nonlinear that we showed earlier, we're seeing the plots generate as the actual simulation is taking place. Also down here we have color-coded leak tracking, and that's one of those things where in gaps that are created in SolidWorks files or any CAD file, frankly, those gaps have a threshold of whether they're determined as a gap or whether they're ignored and essentially sealed up or closed during the simulation. Well, the leak tracking allows us to see those legitimate areas and then be able to go ahead and action on those appropriately as well. Also in the area of SolidWorks plastics, symmetry is a big deal. Symmetry allows us to not have to take what is essentially redundant and simulate it all. So here in plastics we also do symmetrical mold cavities. We have the ability to simulate a part with a single sprue and a runner, and then just by simply determining the star shape or the layout, in this case happens to be 3 in a star pattern, we would get full results but not have to sit through the full simulation of what the total geometry is determined by what we see here. Venting analysis is what allows us to action properly when we find things like air traps, weld lines also, but air traps about venting. This gives us some capabilities to send that air in a particular place, or really just some advice on how we want to tackle the venting of that particular trapped situation. Nominal wall thickness advisor with plastics is really important, because as anybody who does plastics knows, anytime you have dissimilar wall thicknesses, you're going to have dissimilar cooling rates, especially when there's a very thick area. You tend to get sink marks or warpage as a result of that. So nominal wall thickness advisor really allows us to define and design our part more appropriately for plastics usage, not just create an arbitrary piece of geometry and see if it'll fill. So really a great little technology there. And then the mesh improvements. If you see the picture we have over here to the right, those are brick elements. And brick elements, really before SolidWorks, were kind of the dawn of how simulation would be. Now the problem with the brick is that they're more prismatic, which means they're more susceptible to work well with prismatic geometry. So as we got more stylized and CAD products were more capable, we really needed to do something different, which is what we did with our simulation using parabolic tetrahedrons. Well, now these brick elements are resurging, and essentially they're doing that because we're doing something called a non-orthogonal voxel mesh, which allows us to use the brick, but we can change it to more parabolic or trapezoidal types of shapes. Essentially that allows us to use this nice high-quality element, but in parts that are stylized, that have fillets, very thin regions, or curvatures that just need to have more quality based on a more stylized element, and not be relegated to a quality reduction because it had to be some rectangular or square type of a brick. So it's the best of both worlds when it comes to the brick elements and how they can really tailor themselves more to organic geometry. All right, let's go ahead and move over now to optimizing our process a little bit. And this really comes down to our enterprise data management solution. Enterprise Data Management is baked right into Windows Explorer. You use it just like you use regular Windows Explorer, but it layers on all the benefits of revision control, history tracking, check-in and check-out, as well as the ability to have the files automatically brought to your local computer as you go ahead and open them from the vault. Well, in SolidWorks 2015, we've added some tremendous new capabilities, and I'm going to go ahead and show these here in just a second. But I want to talk about each of these. SolidWorks Treehouse is a way for us to predefine assembly structures or interrogate an existing assembly, frankly. There's some great functionality in both of those. There's new quick info icons, columns that are going to show up inside of your Windows Explorer Vault view, not just in your SolidWorks tab. It gives you details and feedback about the status of the file, whether it's the latest version, older, newer, or frankly, whether it's not cached locally, which is a great new function based on this version column. There's also a new private state visibility, and you'll see this in the demonstration. It has to do with when multiple people are putting files in the vault, or at least working in their local vault view, and it gives people with the proper permissions the ability to see the fact that there are files created in another person's computer that are not yet checked into the vault. So that's a tremendous increase to be able to see the visibility of what could potentially be a conflict, especially when duplicate naming is controlled within your vault. Now, on the topic of duplicate naming, you're also going to see where files going into the vault will give us some feedback, not just say that they're a duplicate, but also tell us exactly where those are. And then a bit where the interface with our copy tree, move tree operation, as well as our Windows Explorer Vault view have changed visually. And then some predefined notes that you can have, version comments, and any type of workflow transition, whether it's an automatic transition or manual. We'll go ahead and see each of these live. And lastly, I'm going to finish up here with the new web client. So for those of you who are clamoring to have access outside of the building proper or without a VPN, any device, Windows, Linux, Unix, it's all web browser independent at this point. So you can use your smartphones or your tablets as well. So let's go ahead and run into that really quick here. So when we've got these product structures predefined, what we can do is actually use this new tool. It's actually an old tool. It's part of our SolidWorks Labs capabilities, but it's a new tool called Treehouse. Treehouse allows us to go ahead and predefine by dragging assemblies and parts and structuring them together. Now these are based on property templates, so the properties are the same as they would be as you're starting a brand new SolidWorks file. We're going to name the assembly power pack, and then we're going to go ahead and name a part predefined here as the connector. Once again, they're based on templates, so inputting things like your description, your material, any of the information you want for your company standards can be adhered to. We can also go ahead and set up the configurations at this time. Add configuration names, and then we can even go ahead and determine exactly what part configuration this particular part needs to be. Now, each of these need drawings as well. So by dragging a drawing over to the part and assembly, we can predefine the pack in order to have a blank but ready drawing file waiting to be filled out. Existing parts can be added to this as well. We can drag and drop those directly from Windows Explorer. When you go ahead and drag these parts over and drop them in the proper structure, you even get a thumbnail right away of each of these. Not only can we put them in that way, but we can also determine a quantity at this point as well. When we go ahead and export this assembly back out to SolidWorks, you'll see on the right-hand side here in our vault view that as the structure is generated, the new files will be added to our vault. So here it goes on the right-hand side. You'll see this populate here right now. Okay. So if you do have a top-level manager that wants to go ahead and pre-design these or predefine these, then this can be doled out to the proper user. If you take a look at the connector part, we've got some tabs already in there as we showed, and the third pin configuration is our pre-configured active one. If we look at the check-in dialog, you can see that the parts and the drawings and the assemblies are properly structured as well. So the drawings are aware of the assemblies and parts they're related to. We're going to go ahead and log in as a different user real quick here. I want to show you this from two different sides. So when we take a look at this assembly that we're going to deal with, we actually have to add this power pack to this assembly. Now, we could do this with a traditional method, and first we have to check it out because in data management we need to have right access to this. Instead of using things like insert components, which would be a traditional method, we can actually use Treehouse to accomplish this as well. So over here we're going to throw Treehouse on the left, and then from the right-hand side Recent Files menu, we're just going to drag this existing open assembly into the Treehouse. What it will then do is show you exactly how the assemblies, sub-assemblies, and subparts and assemblies are all physically structured. So from an interrogation tool, I think it's fantastic even just for that. So here let's go ahead and put in an assembly and a part, much like we did in the standalone mode. We're going to call these, though, Power Pack and Connector, the same name as the other parts and assemblies that we generated in Treehouse previously to this. So the vault is set up right now to prevent duplicate file naming, which is an important thing for this. When we go ahead to save this file back into the tree, you'll actually see now that when we export it, the existing open assembly is now going to show the connector and the Power Pack in the SolidWorks tree. So without ever having to close and reopen that file, we get that change. Lower right-hand corner, it's also telling us, hey, there's duplicate files in here. You've got some names in this assembly that somebody else is working on that haven't been checked in. Now this used to be hard to find, but now we have a duplicate file naming box that tells us exactly where the conflicting file happens to be. So we can either do renames if necessary, or go ahead and either use the existing files or go ahead and rename the design that we're working on. It was really a difficult thing to figure out before. So we can't check those files in. Let's just do an undo check out here. This is going to flush our assembly back to the original version. So within its tree now, it's going to get rid of the connector and that top-level assembly. Now we have a version column that actually shows us the details based on icons here in the Windows Explorer view, not just in the SolidWorks view. We still have those two files within the vault. If we try to check them in, it's going to give us a nice error message, but this also has a link to the duplicate parts file naming box. Now this can be a really bad situation when multiple people are doing things, but files haven't been checked in yet. They're just saving them in their local vault view. Previously we had no idea that those files existed until they were checked in, but now we have this new private state. This will let people that have the permission turned on actually see the files that are on individual users' computers before they're checked in. So we can head off these problems before they become big problems. We've changed the Windows Explorer interface a bit as well to make things more clear. You see that we get thumbnail previews for all parts and assemblies on the left-hand side, even in the Contains tab. And the Bill of Materials tab is much more tabular. There's some really simple column and row separations, and again, previews for each of the CAD files there. When we compare, we don't just highlight the entire row anymore. We can actually see that the individual properties or the thing that changed within each of these parts is actually flagged, not just the entire file arbitrarily. When we do a top copy tree, we've added some new information in this as well. It's a better table style, easier to deal with. But what we also see is a settings area at the top, and we could do things like including simulation data, but more importantly, close this area when we're done with it so that we don't take up valuable screen space. We've separated the destination path and file name into separate columns. There was a lot of issues with people changing paths, but then accidentally changing file names as well. This will completely prevent that. And then we have a filter that allows us to look through this tree and simply use wildcards or just typing in names to separate or filter down to things. In this case, we're looking for a part called hip. Easy to do. We also have a very highly requested tool similar to Copy Tree called Move Tree. Now Move Tree will allow us to take a project structure and move it from one area of the vault to another. Before that was quite a manual and very tedious process to make that happen. This one will make it very simple and in a very, very quick manner. Finds the references and changes them all for you automatically. We're going to submit this assembly for approval. When we do transitions, there are several ways to do this, and we have one called parallel transition. That means really a committee is going to go ahead and approve this, so we have to have multiple people here. So here we're going to go ahead and put these in. Now in SolidWorks 2014, EPDM 2014, it would overwrite the previous approver when the second and other subsequent approvers would have to do that. So we're going to go back in now as a different user here and continue this process so that we can see the effect of multiple users. Now we have the ability to actually map the variable of the individual approvers in chronological order. So now you can see at the bottom here, the history shows a previous approver already there, and now Ian logged in is going to approve this as the second person. And then once the second approval happens, this will automatically trigger the state change. And this is really how those parallel approvals show. But here we've mapped the properties to the data card, and we can see very plainly who actually approved it and when they approved it, and really in what order as well. The way this happens in the admin tool under our actions is that we're mapping the approvers to a property or a variable. The version comments can also be much more colorful here. We've got some names that are going to inject based on who did what and what date. We used to not have any type of comment on an automatic transition, which really didn't, leave your history looking very tidy. Here we're approving multiple, and if we map these people from both the approver 1 and the approver 2, then they can go ahead and approve it in any order, and they will simply show up in the property in the order in which they approved. Once again, revision comments here on this automatic transition, and that'll make our tree view much more pleasant. We're just going to run this through a couple of more workflow transitions just so we can generate a few more revisions for this. So now when we look at get version, we're going to see all the comments, which again are very, very valuable to the right-hand side there, even the ones that were automatic. So the dates are injected and the user logged in at the time automatically input. History on the right-hand side no longer has blanks based on automatic transitions. There are comments made for everything, whether it's a manual process or automatic. And now when we roll back, we can also put a reason why. There's a new web client now I mentioned before. The web client itself is basically browser independent, which is the most important part of it. You can look at it on a smartphone, any tablet, iPad, iPhone, or Android. When you log into the Vault view, you can go ahead and look at the different structure that we've got. And as you select things like our assembly, you'll get all the feedback and information. Data card simply accessible. You can also drill down and get other information like the contains and the where used. And if you are remote and you want to use this file, you simply check it out, download it, make your changes, and then upload it back in. You can even participate in workflow state changes here or from your smartphone. Down at the bottom, if we click mobile version, you can look at it differently on a smartphone, which might be a little bit more pleasant interface. A little bigger, a little easier to click. It's going to go ahead and just be a more pleasant experience on an iPhone. So great new interface changes for EPDM. This is not an additional purchase. Web 2.0 is part of your existing Enterprise PDM licenses. It's just a matter of grabbing the proper download, and usually it's a reseller-assisted installation. So if you are interested in this, get a hold of Decide Solutions through tech support and just simply initiate the process with your salesperson if you'd like, and we'll get to that as to how to either instruct you to do the Web 2.0 upgrade, or we can come by and work out a time to be on site for you. So last couple of things I want to run through here are going to be just basic SolidWorks functionality again. Let's go into some drawings functionality. Now, even though we have many mechanisms for going fully paperless, most people are still creating 2D drawings for shop floor purposes or even just basic communication. So with the drawing that I want to show you right now, there are several nice new functionalities when it comes to not only visualization of things, but really getting more and more data and feedback from the system. We're going to take a look at the assembly in the upper right-hand area here. It's got a bunch of balloons. I'm going to window select each of those balloons, and there's a new balloon leader type. So if we go to more properties, you'll see it right down here. It's called the spline leader. The spline leader instantly converts all the selected balloons over to a really nice little squiggly look to it. And this is really what you'd see, I think, if you're looking at pattern drawings more often. Now these splines happen to be style splines, so you can change those any way that you'd like to just by manipulating the prismatic inputs around those, so they are quite flexible into their layout. Now, since the dawn of software and even down to drafting boards, we've had these tick marks that reside around the sides and the rows of any type of drawing template or title block. Well, these are called zones, and the zones are actually something completely usable now in SolidWorks 2015. I'm just going to go up to the View pull-down menu and actually show those zones. But these zones can be defined and columned and rowed in the proper order so that they fit on even imported AutoCAD data. They're not something that comes necessarily on a SolidWorks template. So you'd have the ability to stretch the window so that it meets just the corners, and then the proper number of rows and proper number of columns in order to match up with each of these tick marks. Now once that takes place, it's a lot of feedback from a couple of different areas, one of which is revisions. When we go ahead and add a new revision, not only does it add a new row to the revision block, but it also puts the symbol on our cursor right away. And if I place a symbol next to a dimension, you see that the zone number of that symbol pops in automatically. If I do that over here next to a balloon, again the zone number of that balloon now shows up as well. And if we start dragging these around, you should see that those zone numbers are dynamically changing. So it is very, very smart. Really no way to break the connection between where the zone resides and where that symbol happens to be sitting. These zones are usable for another area of the software. And this has to do really more with the relationship from a parent to a child view, especially when multiple sheets are involved. It's under the Annotations tab, and it's called a location label. Now, location labels cannot be inserted to a view that doesn't have a child. Now, some of these are front, top, and right views, and they'd have child views, but we're talking sections and details with this. So if I go ahead and hover over my section and my detail, by simply clicking on the detail circle, it's going to give me a nice zone of Sheet 1, Zone B1, which is where this detail view is sitting. And if I go ahead and click on this view, now we see Sheet 1, C4, which is the center of mass of this particular view. So this is a completely associative thing as well. If I was to use my feature manager to drag that detail view from Sheet 1 over to Sheet 2, you'll see that the zone and the sheet are going to go ahead and change. The zone stays the same because the part itself is going to sit in the same lower right-hand corner on the next sheet, but the sheet number obviously is going to be in tune with where that view now resides. You can turn those on and off visually anytime that you'd like to, though the zones are still going to be fully associative as a result. Down here in the lower right-hand corner, I want to look at some center marks. Center marks are one of those things where, based on changes, these can go broken. And it's just a fact of how parametric systems work. I'm going to open up this assembly in this view. I'm going to right-click inside the view, and instead of choosing the original open part file, we have another one to the right of it that actually says open part in position. Now, regardless of how that part file was saved in 3D, it will open it, and then it will rotate it around into the position of the view that I just interrogated. Now, in order to go ahead and simulate a problem, we're just going to go ahead and edit our whole wizard component. And by going to positions, I'm going to add a couple of additional points. But to break something, I'm going to delete an existing point as well. What that'll now leave us with is 5 holes instead of 4, but they're different holes than they were before. At least a couple of them are. Now when we go back to the drawing, you'll see the nice olive color that we put on anything that's got a dangling or broken relationship. Well, here we'd have to delete and redo that in previous releases. Now a simple right-click on that center mark allows us to reattach. And by reattaching, I can pick any other hole, and it will simply put it back in and reassociate. Therefore, if there are any dimensions or other annotations attached to that center mark, we don't have to delete those as well. Well, now we've got an additional hole, though, and that one doesn't have a center mark. So a right-click on this bolt hole circle gives us an operation that we can add a center mark. Simply click the new hole, and we've got a new associative center mark in addition to the original ones. There's 2 other things that I want to show on this drawing. Now, one of which might affect a handful of you out there, but I want you to see exactly what it is. And it's these dimensions here, 68.3 and 48.3. 68.3 and 48.3 are actually 0.25, each of those, but we're rounding up just with the normal standards that we've rounded up to since the dawn of design. Well, there's other people that don't necessarily round that way, and you might not be aware of these disciplines, but they are out there. If you go to your unit switcher and simply go to Edit Units, it's the quick way to get to Tools, Options, and Document Properties. But we have new rounding options here that allow us to round half away from 0 or round half towards 0, which is going to be now half up or half down, and then round half to even, the next even number, or truncate without rounding. Now, each of these values, in some cases, is going to result in rounding up. So 0.325 would actually, 0.25 would actually round up to 0.3. And you get my drift. We're going to round up on anything that could be above 0.0. So if it's a 0.1, we're going to round up. The reason we do those kinds of things is because in wiring and piping, you'd always want to cut it longer than it needs to be, never shorter. So rounding isn't necessarily always going to be, once you get to 0.3, you're going to round, or 0.5, you're going to round up. This as a 0.25 would round up to a 0.3, but this as a 0.22 would also round up to 0.3 in the proper scenario. Again, wiring, electrical, and piping, you always want it longer than you need, never shorter. The last thing I want to show is this one down here, and that's a note. I'm going to take this note and actually change what layer it happens to be on. We'll just do that using our layering tool up here. So if we show that tool live, we're going to take that note, and let's just go ahead and switch it over to the security layer. Now by doing that, what's going to happen now is that this note is going to be on a layer that we have determined to not print. So we now have a new column here that allows you to disassociate or disallow any type of layer from printing. So as long as we verify that this particular note is on the security layer, if I was to go ahead and do a simple print preview, so we'll just go ahead and take a look at it that way, you can see that in the print preview that note does get scrubbed away. Now if you print to a PDF, it will also scrub that note away. That's a print operation. It's just to a PDF generator. But if you save to a PDF or save to an e-drawing, it does not apply. So very specifically, that will not print does refer to printing as an operation. Okay, last thing that we're going to run through in today's session is some visual changes made to eDrawings. eDrawings has been available for Android and iDevices for a couple of years now, and it's more of a tablet look and feel, you know, kind of where Windows 8 happens to be going as well. And they've changed eDrawings on the desktop systems to look a lot more like the eDrawings of mobile. It also now supports things like custom properties, named views that you've saved in your 3D files, even simulation results, plastic results, and it works on the Android operating system as we mentioned before. So with this one here, let's open up a couple of different eDrawings. The eDrawings that I want to show you on this one are a couple of different. We got some simulation results. That's the first thing I'd like you to see. And since we did simulation with the Load Case Manager previous, this one really should show nicely. What we have here is an eDrawing, and of course you can see that we have our simulation plots showing information from the feedback of that plot, as well as our loads and boundary conditions. And if you take a look down here on the bottom, all of the tools that we used to have peppered in different areas around eDrawings are really just along the bottom now. When it comes to simulation, we can go ahead and take a look at the studies that are here. And in these studies, we can actually see the different plots that are here as well. So if I want to look at the stress plot versus displacement versus factor of safety, we can see all those quite easily here. We also have the ability to turn on and off the display of the different loads and restraints. So over here, I'm removing my fixtures. Down here in the bottom, I can remove my forces. So simple visual elements. You can get rid of the legend, turn that back on, or even go ahead and show or hide the mesh. When we're dealing with plastics, it's going to show you the feedback of plastics fill time. It's not quite an animated type of a fill just yet, but it will give you the feedback of any of these plots that we do within plastics. Once again, you look at your plots, you're going to see your plastics fill time, and then the surface plot associated with that. When we're opening up assemblies or part files with eDrawings, you're going to get things like your part properties or your file properties. All of these things are now located in the lower right and in the lower left area, so all the buttons that we had there previously. If I wanted to go ahead and explode this, of course, the button's going to be down there for exploding. Animate's going to animate from one view to another if it was a drawing, or from front, left, top, right, and throughout if it's a part or assembly. Of course, the Move tool is always there. Depending on what you selected, the Move tool will then pop out different tools with different specifics. We just want to go ahead and do a free drag, we can do that as well. But there are different inputs that we could use specifically with the deltas that we've changed there. Measurement is also down there. Once again, based on how you measure or what you select will be within that tool. And then down here we've also got our section tool. Easy enough to go ahead and flip the direction of the sections, go ahead and change what plane we're actually using for the sections, but in a very easy to use type of a format. Markups are the one thing in annotations that I find to be just a little bit of a hard discovery for a new user, so I want to show you this in a little bit more detail. If we take a look down here for annotations, annotations are going to be different things. Could be a new comment where we do a balloon or a note or some sort of drawing, or even insert an image at this point. But what you do now is you say you want a new comment, and I'll show you why this is. If I was to come in here with a new comment and go ahead and take that new comment and then simply make a note, for example. Maybe I want to go ahead and put in a type here. Let's just put a balloon. I'm going to call this something. I'm still in the middle of a comment, so I could come in here and also put another note in a different spot with something else. And these are all part of the exact same comment. Prior to that, it was a little tougher to group these kinds of things. If I wanted to then separate these out, I could maybe rotate this file around, do a new comment, and then from there maybe do just something else. So there's a couple of things up there. Maybe I'll just draw something. Just draw a circle around an area. So each of these comments now is a separate type of a thing. It's got multiple elements within it, and then there are different points of view for those especially. If this is an eDrawings Professional, which this is, that would allow me to save the markup and or save the eDrawing. The markup could be inserted into the SolidWorks file from here, or we could go ahead and actually, if we're opening up native SolidWorks drawings, have those markups appear directly within the SolidWorks interface. So that's what we have today for part 2 of our What's New in SolidWorks 2015 webinar series. I want to go ahead and just check the webinar interface here for a second and see what kind of questions we might have out there. We'll see what we can do here. So regarding plastics, can you model the likely warpage and then use the warped model for your tooling? You know, I have to actually check on that one, Sean. We have a thing in our other simulation tools where you can save the deflected model. So if you do have a displacement in a static simulation, the deflected model could effectively serve as a nice interrogation piece for what would be spring back. So when it comes to the plastics model, though, it's going to tell you where warpage will occur, but there's not necessarily a displacement or a warpage simulation taking place there. So it's more or less feedback, not actually showing you the warped change. So my guess is going to be no, but I can check into that one. And then this one here is, do you have the ability to pull a serial number into the treehouse option? Not really quite sure exactly what the question is with that one. Serial numbers into treehouse would, it would just be a property that has to go along with the file. So if there was a property that was a serial number, then that might be an effective property that would be accessible through there. But it is for structuring any type of part assembly and drawing. So if those document templates have a property called serial number, then that would be something we could use. But we can't use it to auto-name like we would inside of EPDM. Now, there your question just came through. Thanks a lot, Cheryl. I do not know of a serial number generator for that product as of yet, but that would be a fantastic enhancement request for those. So I do appreciate the addition of that question. All right, with that, I just want to thank everybody for spending their time today for us. We got one more thing, which options are included in Standard, Pro, and Premium. The plastics is a bolt-on. You can put that on every part, every type of SolidWorks license, whether you have a Standard, Pro, or Premium, but it is not included in a Pro or Premium. So again, this was what options are included in them. The Treehouse tool is part of EPDM 2015 as well as Web 2.0. Those are all native new enhancements to the product, so nothing addition to that. Any of the other simulations that you saw, the nonlinears and dynamics, those are all part of the simulation products, which also can be added to any version of SolidWorks, Pro, Premium, or Standard. And then, of course, in SolidWorks Professional and Premium, there's Workgroup PDM, which is not Enterprise PDM. They are quite different. Enterprise is controlled by a database, and Workgroup is a flat file structure. So once again, I want to thank everybody for spending an hour with us here during your lunchtime. I hope you had a good lunch and a little bit of relaxing time to pick up on what we've added to the product this time around. We're going to take this recording and save it to the website, so once again, any of your colleagues can come out here and take a look at this whenever they'd like to.